Hello dear students, welcome back to the class. So here you can see we are going to wrap up the chapter with the question pattern exercise, the CBSE pattern exercise, where you are going to see the number of questions which will be from the chapter communication system, and the category of the questions will be a 1 mark question, 2 mark question, 3 mark question. Basically the difficulty level will be a little bit higher according to the marks allotted, and the questions are from the previous year your board exams or the sample question paper. So quickly just wrap up the chapter with the question answer session. So question number 1 to 3, as you can see, is the 1 mark question. So we are not going to go into the detail of the question, we are just going to give a 1 mark question according to the 1 mark. Yeah. Okay, so the figure given below shows the log diagram. It is not the log diagram, it is the block diagram. The block diagram of a generalized communication system. So identify the element labeled X. So this is the element labeled X, this we have to tell, and we have to write its function. So as I told you while teaching you the chapter, if this is the block diagram of a communication system, then this is the information source, this is the transmitter, this is something that we have to guess, and this is the receiver, then this is the user or the receiver. So yeah, this must be the channel where your message is going to be transmitted, through which your message is going to be transmitted. So we can say this X is nothing but the channel, and we have to write the function. The function of channel is to transmit, or it is a medium to transfer a message from one point to another. Without using the channel, you cannot transfer your message from one place to another. Okay? So this is the channel and this is the function. So quickly go to the question number 2, because this is a 1 mark question, we just have to give to the point answer. Question number 2 says, why are the broadcast frequencies or the carrier waves sufficiently spaced in amplitude modulated wave? When we are speaking about sufficiently spaced, this directly means that we are making a higher, you can say the broader categorization of the waves. And why we are doing so? To avoid the mixing up of signals during the transmission, we make the waves, or we provide the space very sufficiently to a greater extent. Why to a greater extent? Because we can answer the question like this. To avoid mixing of the signals, again it is a 1 mark question, so just 1 line will be enough. To avoid mixing of the signal while transmitting the message, that is why we are using or signal. That is why we are providing them sufficiently spaced. That means they are very much distant apart so that they get not mixed up while transmission, because at the moment the waves are transmitting, the message is transmitting, so there is a possibility your message will be mixed up, because during that session there will be number of waves that will be transmitting, and there will be a possibility that they get mixed up. So to avoid the mixing up of the waves, we provide a sufficient space between them. Okay? So now move to the second question. The third question. How does the effective power radiated from an antenna depend upon the wavelength of the signal to be transmitted? I remember I told you very clearly that the power radiated, the formula of the power radiated is L upon lambda whole square. So if this is the formula, you can directly say the effective power radiated from a linear antenna depend on the wavelength by this relation. That means P is inversely proportional to the power radiated. So that means to get the more power, for more power your wavelength should be less, or consequently you can say when wavelength will be less, frequency will be greater. This is the conclusion out of here. So when you are saying that the relation we have to find between the power radiated and the effective length of the antenna, then we are having the relation like this, and this is the conclusions that we can draw out. Okay, simple as that. Next question. Now the category has been changed. Question number 4 to 7 are the 2 marks question. So mention the function of any two of the following used in communication system. It is up to you which you are comfortable with. You can give the definition of that too. But to make you understand, I am going to give you the definition of all the 4 terms that has been written over here. The transducer. Transducer, I told you, it is a device which convert one form of energy to another. And I remember I also gave you the example of photocell. Photocell is a device which is used to convert the light into the electrical energy. So this is the example of transducer. Now repeater. What do we mean by the term repeater? Repeater is a device which is a combination of receiver plus amplifier plus transmitter. This is the combination of 3 things: receiver, amplifier and transmitter. You can write this as receiver, or directly you can say repeater. Repeater picks up the signal from the transmitter amplifies it and transmit it to the receiver. Now see, I told you the example of repeater, what is the function of repeater and where is the repeater used. I told you when you have to transmit your message and there is a mountain or any obstacle within your path, then you are going to use the repeater to extend your range of communication. So the benefit of using repeater is to extend the range of communication. Okay. So third one, the third term says the transmitter. Now you know that transmitter, the role of transmitter is to transmit the message or the signal. So we can say the transmitter is again the full package of source, message and the transmitting, or you can say the modulator. So we can say transmitter is a device which is composed of source, message, or you can say the signal and modulator, which will modulate your message and transmit it to the receiver or to the other end. So this is your transmitter, a package of these 3 things. Now for lastly, band pass filter. This band pass filter is an you can say very good thing that we are having if we want to filter the frequencies. Now you see, you are having your camera in your phones and you are having so many filters in that, and you are using the filter to change the color variation on your face, to change the background color and so many things. Similarly, this filter is used for frequency. This band pass filter will allow only certain frequencies to pass through it. It will reject the higher frequency, it will reject the lower frequencies, and only it will allow the band of frequencies to pass through it. That is why its name is band pass filter. So, I am going to write the definition so that you can note it down. Band pass filter. It allows only certain frequencies to pass through it. Or we can say it rejects the higher and lower frequencies and only allow the band of wavelength or frequencies. So, this is the band pass filter. Okay, so now we have given all the 4 definition. Whichever you are comfortable with, you can learn that and you can write in your exam. Okay, so the next question number 5, a message signal of frequency 10 kilohertz. Message signal of frequency, that means omega m has been given as 10 kilohertz and the peak voltage is 10 volt. Here we are talking about the message signal, so definitely the peak voltage of message signal is 10 volt. Secondly, it is used to modulate a carrier wave of frequency 1 megahertz. So, the carrier wave frequency is given as 1 megahertz and the peak voltage is 20 volt. So, the peak voltage of the carrier wave is 20 volt. Now, we have to determine the modulation index and the side bands produced. I told you what is the formula of modulation index, EM upon EC. You can write the modulation index either as MA or as MA in subscription, or you can write it as mu. So, this is the formula EM upon EC. You can directly put the value of EM and EC and find out the modulation index. So, this is 10 upon 20 or this is 0.5. So, the modulation index is 0.5. Second one, the side bands produced. I told you the formula how to find out the side bands. The side bands is omega c plus omega m, this is the upper level, and the omega c minus omega m, the lower band. These are the side bands, this is the upper band and this is the lower band. So, we can directly find out the omega m and omega c. So, omega c plus omega m. So, 10 kilohertz plus, now see this is 1 megahertz, we can convert it into kilohertz. So, 1 megahertz is 1000 kilohertz. So, directly we can add them up. So, 1 will be 1010 kilohertz. This will be the upper side band. If I talk about the lower side band, you have to find the omega c minus omega m. So, omega c is 1000 kilohertz minus 10 kilohertz. So, that means 990 kilohertz. This is your lower side band. Okay, the question was very simple, you just have to apply the formula and get the answer. So move on to the next question, question number 6. What is the line of sight communication? This is the first part, and the second part, why is it not possible to use the sky wave propagation of transmission of TV signals? So we will be dealing with first of all the first part, which says that what is line of sight communication, which we also call as LOS, that means line of sight. So I must tell you, dear students, that LOS is a type of communication. I am going to write the definition so that you can take a note. It is a type of communication which is used to transmit and receive the message where the transmitter and the receiver are visible to each other. Its example is FM radio or the microwave or satellite communication. Microwave or satellite communication. This is the example of LOS. So line of sight communication is also called as the space wave communication. This is the line of sight communication. Line of sight, sight means where you can see the things. So this is that when transmitter and receiver they are able to see each other, they are visible to each other. That is why this is called as the line of sight communication. Okay. The second part, why it is not possible to use the sky wave propagation of transmission of TV signal. First of all, try to understand the question. The question says that if we want to transmit the TV signals, then instead of using the space wave, the sky wave propagation, we are using the antennas or dish TVs, through which we are using the cables. So that means we are using the ground wave communication, but not the sky wave propagation. What is the reason? The reason is simple, that the TV signals, the range, the frequency of TV signals, frequency of TV signals is 110 to around 220 megahertz. This is also 110 megahertz to 220 megahertz. This is the frequency of TV signals. But if we want to apply the sky wave propagation, the sky wave propagation only transfer the message only transmit, or you can say only reflect back the wave, the signal of frequency 30 megahertz. 30 megahertz. So that means if you are using this much of frequency, this will not be able to reflect it back with the sky. It will transmitting to the sky and it will not be able to come back to the earth. So we have done the 6th question. Take a note of this. Take a note of this definition, because again it is an important one, so that I can begin with the next question. Okay. Okay. So if you would have taken note of this, let me start telling you the next question. But before going to the next question, just take a note over here. We have written receiver the signal where the transmitter and receiver are visible to each other. Yes, that is correct. But one more thing that you should add in your definition is that without any sort of obstacle in the path. Without any sort of obstacle in the path. This small line should be making the definition more important to you. So you can add this line. Now we will be moving to the next question, which will be the question number 7. Okay. So the next question says, define the term modulation, draw a block diagram of a simple modulator for obtaining AM signal, amplitude modulated signal. So firstly we have to define the term modulation. Can you tell me the word modulation? I told you number of times. Modulation is a process of superimposition of a message signal or you can say the modulating signal of lower frequency to a, while we are superimposing a modulating signal to a higher frequency carrier wave, this process will be called as the modulation. So this is the process or you can say the definition of modulation. We have defined the term. Now we have to draw a block diagram of a simple modulator for obtaining AM signal. So let's start making the block diagram. This is the modulating signal. You can write this modulating signal as MT. Now here there will be the addition of the carrier wave, which we will be calling as or denoting as CT. When the both will be added, they will be passed through a square law device. After that, it will be allowed to enter band pass filter. And then it will be your amplitude modulated wave. Now see, this is the block diagram of the AM signal. Here you have to understand what we are having with us. This is the XT and this is the YT. This is a square law device. This is that device which will produce a non-linear AM wave. This is basically made to provide us a non-linear wave. So this will provide you with the non-linear wave. Here it will be providing us the combination of modulating and the carrier wave. So XT is nothing but, you can write this as AM sin omega MT plus the carrier wave AC sin omega C into T, and this YT is nothing but, you can say, plus D into X square T. This is something like that, and this is the function of this is to provide the linear relation. So here we have to just draw the block diagram. We don't have to give the role of these two things, but if you will be giving the role, that will be a plus point because this is a 2-mark question. And now the band pass filter, this I already told you, it will provide only a certain range of frequency. It will allow to pass through only certain range of frequencies. Yeah, so this is 2-mark question. So I don't think you should add these two things. This will be enough for you. So now start doing the next question. That will be the question number 8. Question number 8 to 10 is 3-mark question. So firstly, how is amplitude modulation achieved? We have to show how do the amplitude modulation achieve. This I already covered in the lecture, but here also I am going to tell you quickly. The process is same, that modulating signal will be superimposed on a higher frequency wave that we call as the carrier wave. When they will be superimposed, we will be having the amplitude modulated wave. So see, or you can say directly draw this. This is your modulating signal. This is your higher frequency wave, that is carrier wave. When the modulating signal will be superimposed, the wave will be like this. And this will be like this. Hope you understand what do we mean by this. So this is your modulating signal and this is the amplitude modulated signal. So this is the diagram that you can show while explaining the answer, and directly you can add 2 points, 2 lines, that when we are superimposing the modulating signal with the higher frequency carrier wave, we will get the amplitude modulated wave. Second question, the frequencies of 2 sidebands in an AM wave are 640 kilohertz and 660 kilohertz. So let me just remove this and start doing the numerical. Frequencies of 2 sidebands in an AM waves are 640 kilohertz and 660 kilohertz respectively. Find the frequencies of the carrier and modulating signal. Okay. This I can write as 640, 660. Two sidebands. So sidebands are omega c plus omega m and omega c minus omega m. So you can make a change, a little change. The change is that firstly we will be writing the omega c minus omega m. So omega c minus omega m, this omega c plus omega m will be this much. Now see, we have to find the frequency of the carrier and the modulating signal, which is very easy for us to find because omega c minus omega m and omega c plus omega m has been given. So you can directly apply the elimination method, the mathematical relation, and find out the value. So this 2 will be cancelled if you will be considering this as equation 1 and 2. Using the elimination method to solve these equations, you will be having 2 omega c equals to 1300. So omega c will be 650. Yeah, omega c is 650. Now similarly you can solve again to find out the omega m. So omega m will be find out as, you will be considering the negative sign, negative, negative. So this will be cancelled and you will be having minus 2 omega m equals to minus 20 kilohertz. So that means you will be having omega m equals to 10 kilohertz. So this is how you have found the two frequencies, that is frequency of carrier and the modulating signal, omega c and omega m. Now what is the bandwidth required for amplitude modulation? See, this we have been said as upper sideband. This we told as lower sideband, omega c minus omega m. Frequency, if they are talking about the bandwidth, bandwidth can be found out as upper sideband minus lower sideband. So you can directly find 660 minus, now remove the negative sign, this I have shown to make you understand. 660 minus 640, that is 20 kilohertz. This is your bandwidth. You can also find the bandwidth from these two equations, where you can find out the 2 omega m equals to this thing 650, or you can directly put this value to find out the equation from this value. Okay, simple as that. Now let's start doing the next question, question number 9. The optical communication system having an operating wavelength lambda in meters. So we have been given the wavelength lambda. So let me start writing the specifications given. Wavelength has been given as lambda. In meters, can use only X% of the source frequency. So let us say if the source frequency equals to X, so we can use only X% of source frequency. That means, oh sorry, I have considered this as nu, because frequency, I am considering the frequency as nu. So X% of nu will be used. Okay, start reading the question. Source frequency as its channel bandwidth. The system is to be used for transmitting TV signals requiring a bandwidth of f hertz. So bandwidth has been given as f. How many channels can this system transmit simultaneously? Assuming all other factors to remain constant, show graphically the dependence of the number of channels that can be transmitted simultaneously on the operating wavelength of the system. So to find out the relation, to show the graphical representation, first of all we should do one thing, we should find out number of channels, how many channels. So n we have to find, suppose the number of channel is n. So you know that we are using only X% of frequencies, and I told you the formula to find out the number of channels is nothing but available frequency, or you can say the frequency used upon the available frequency, or the bandwidth you can say. Okay, this is the formula. Now you can use this value simply. How? Frequency used is X% of nu. So this can be written as X upon 100 into nu. Now because we have been given the wavelength, we didn't given the frequency, we haven't given the wavelength. So we can convert nu equals to c by lambda. So we will be putting this over here. So this will be X upon 100 into c upon lambda. So we will be putting this value to find out the number of channel. Now n will be equals to frequency used. Frequency used is Cx upon 100 lambda divided by available frequency, that is the bandwidth, that is capital F. Now see, we are having the relation in terms of number of channel and wavelength, and in the question we have been said that we have to show the dependence of the number of channels that can be transmitted simultaneously on the operating wavelength. So wavelength and the number of channels, that we have to draw the graph and we have to show them. So here you can say n is inversely proportional to lambda, right? Inversely proportional. So you can directly make a graph if this is n and this is lambda. So the graph will be like this. This is simple as that. Okay. So firstly you have to derive this relation, only then you can reach up to this point. Okay. So without wasting our much time, we should now move to the next question and the last question of the session. A signal is to be transmitted along a cable system of total length 125 km. The total length of the wire is you can read the question. During that I am writing this 125 km. The cable has an attenuation of 7 decibels per kilometer. See, at per kilometer 7 decibel of attenuation is being done. So if I will be talking about the total attenuation, as I can see, amplifiers each having a gain of 43 decibel are placed at 6 km intervals along the cable. State that what is meant by the attenuation of the signal. First of all, we have to give an explanation what do we mean by the attenuation. So you can say that attenuation is the factor which, or you can directly say the power loss during the transmission of the signal is called as the attenuation. So write down power loss during the transmission of signal is attenuation. Secondly, calculate the total attenuation case caused by the transmission of the signal along the cable. Total length of wire has been given as 125 km, and at per kilometer, at 1 kilometer, attenuation is 7 decibel. So what should be the total attenuation? 125, that means total length of the wire multiplied by 7. It would be is it correct? 7 5s are 35. Okay, 875 decibels. This is the total attenuation. This is the second part, B, first part. Now second part of the B, the total signal gain as a result of amplification by all the amplifiers along the cable. Now see, we have to find the total signal gain as a result. So see, amplifier each having a gain of 43 decibel. We know that each amplifier will give a gain of 43 decibel. So we have to tell them the total signal gain, but for that we need to know what is the number of amplifiers, but we don't know about that. To find out the number of amplifiers, we are going to do one thing. We know that we have been given one more thing, they are placed at 6 kilometer intervals and the length of cable is 125 kilometer. So, to find out the number of amplifiers, will be equals to 125 kilometer per 6. At every 6 kilometer one amplifier is placed. So, it will come nearly 20 when you will solve it. So, now you know that number of amplifier is 20 and what you have to find? The total signal gain. One amplifier gain is 43 decibels and we have to tell the total signal gain. So, total signal gain will be number of amplifiers multiplied by amplifier gain due to the signal. So, 20 multiplied by 43 . 860 decibels. This we have the total signal gain. The second part is done. Now, third part, that is the C part, says that input signal has a power of 450 milliwatt. Use your answers in B to calculate the output power of the signal as it leaves the cable system. Again, you have to apply one formula and the question is simple. Okay, see, firstly we have seen the total attenuation and the total gain. Total attenuation was that I have deleted 875 decibels and the total signal gain is 860 decibel. So, if I speak about the total gain, so total gain will be only be achieved when we will be doing one thing, when we will be subtracting this total gain, signal gain minus the attenuation. So, we will be having minus 15 decibel as the total gain. Now, see, we are here to find the power output. So, there is a one formula that you have to remember and that you have to learn to find out such question. To calculate the output power of the signal as it leaves the cable system. So, firstly, power input has been given as 450 milliwatt. See one thing, the formula that why do I have found this thing? Total gain or loss is equals to 10 log P2 upon P1, where P1 is your power input, P2 is your power output. So, you have to find out the power output, that means P2. So, when you will be putting the value minus 15 over here equals to 10 log P2, that we have to find P1. Now, P1 or P input 450 milliwatt. You can write this as 450 into 10 raised to the power minus 3 watt. When you are going to solve for it, you will see that P2 will came out to be 14 milliwatt. Okay. So, the question was simple. You just have to apply this formula. You have to learn this formula. Total gain or loss will be equals to this. That is why we have found the total gain. And total gain was found out using your signal gain minus subtraction, minus total attenuation. So, this is how such questions can be done. This is it for today's class. We will be meeting in the next chapter. I think this was the last chapter of class 12. So, we are done with the class 12 physics. Just keep revising and keep practicing. Take care. Thanks a lot.